Hello everyone, we are going to continue with our calculus and linear algebra questions. If you haven't seen the other questions, that is question 1 to 3, I'm going to link them up above in the video and you can check that out. So today we have been given a function f of x to be sine of x on x plus x all over x squared minus 1, and we have been given a couple of statements to verify if they are true or false. Now, whenever we're given a composite function, because this is an example of a composite function made up of more than one function, then we have to treat them as individual functions and draw our conclusions. So what do I mean? Now let's look at it. We have our function f of x to be sine of x on x plus x all over x squared minus 1. The first statement says that the line y equal to 0 is a horizontal asymptote of f. Now, what is the definition for horizontal asymptote? We know that to get the horizontal asymptote, we are looking for the limit as x tends towards infinity of our function f of x. If it happens that this limit is, let's say, a constant a, in this case 0, then y equal to a is our horizontal asymptote. So you have to know this definition. That's the definition for horizontal asymptote. So we are going to basically apply it above here, meaning that we're going to check to look for the limit. Since there are two functions, let's consider the first function. We can call this function g of x and call this function h of x. It is easier to compute them separately like this. So if we consider h of x, right, then we want to look for the limit as x tends towards infinity of f of h of x. So it is very easy. The result is 0 because we can factor out x here. We are going to have 1 on the numerator, then we factor out x on the denominator. We have x minus 1 on x. So we notice that the x is going to cancel and we are simply left with 1 on x minus 1 on x. Remember that we are dealing with the limit as x tends to infinity of this. What do we know? We know from our assumptions that the limit as x tends to infinity of 1 all over x is 0. What am I trying to say? Meaning that 1 on infinity is 0. You have to know this. It's a rule. You have to know that 1 on infinity is 0. So if we want to apply that in our equation here, we notice that the limit of this function as it tends to infinity here will be 0, right? We already saw that from here, and this will be like 1 all over infinity as well, which is equally 0, right? So we know that this limit h of x tends to 0 as x tends to infinity, so this would tend to 0. Now the interesting part is sine of x all over x. So g of x is a sine of x all over x. So we want to look for this limit as x tends towards infinity. In this case, if you substitute your result, you're going to have infinity, because sine of infinity is infinity and infinity. So this is indeterminate. It's undefined. You don't know the exact infinity, right? So in this case, we're going to use a different approach using the squeeze theorem. Then we are going to bound our function. To bound our function, you start with a function with boundaries, right? In this case, we have sine x, and we know that sine x is defined between 1 and minus 1. That is our sine function. Our sine function is defined, right, within this range. It oscillates between -1 and 1. Now we are going to divide all through by x. Why am I doing this? In order to have our original function. So this will be sine of x divided by x less than or equal to 1 on x, right? So what do we notice? We notice that this is our g of x. Therefore, meaning that if we look for the limit of as x tends to infinity of our -1 on x, and this limit happens to be the same as from, this is like the limit from below, this is from below, and this limit happens to be the same as the limit from above as x tends to infinity of 1 all over x. Therefore, we can conclude safely that the limit of this value, let's say if this value is a, therefore the limit of this value of the result will simply be the same as the limit of our function of g of x in this case, which is sine x all over x. So that is the explanation of the idea behind this function, right? Behind this. So in this case, we have the limit of g of x will simply be a. We don't necessarily need to compute the function directly, but we can get that from its bounds, right? So as we saw earlier here, the limit of this function is always 0. So the limit here will give us 0, the limit here will give us 0. Therefore, g of x, the limit will also be 0. The limit will also be 0. That's the whole idea behind that. Since we saw that the limit of our function g of x of h of x was 0 and g of x is 0, therefore y equal to 0 is a horizontal asymptote. This is a true assumption. This is a true assumption. So we have to keep that in mind. We have to keep that in mind. So that's it for this. And the second option B says that the line y equals to 1 is a horizontal asymptote of f. I don't think this is correct. Why? Because we've just seen that y equal to 0 is our horizontal asymptote, and we didn't see any function of y equal to 1 to be the horizontal asymptote, so that is wrong. F has a vertical asymptote at 0. Now this is an interesting one, and let's calculate that. Let me create some space. So this option C says that f has a vertical asymptote at 0. So what's the definition of vertical asymptotes? Let's look at this. To look for the vertical asymptote, we simply look for the points where the denominator is 0. So in this case, for the first function, if x is 0, our composite function that we saw, g of x, and here was h of x, our function will not exist. Therefore, this will be a vertical asymptote. Now this is true, right? From this function, this will be a vertical asymptote. Now the second option says that f has a vertical asymptote at 1. How can we know that? This is also true because we know from h of x that x squared minus 1, if we set that to 0, it's going to give us our vertical asymptote. And this is a difference of 2 squares, so this will be x plus 1 to be 0. Therefore, x equal to 1 and x equal to minus 1, they are all vertical asymptotes. So this statement is true, it's correct. This statement is correct. This statement is correct. And the last statement says that f of 0 is 0. Now this is not necessarily correct. Why do I say so? Now let's look at it together. The equation says that f of 0 is 0. Now let's look at it. If we look for f of 0, we simply substitute it as 0. We are going to have sine of 0 all over 0 plus 0 divided by negative 1. Of course, this is going to give us 0, but this doesn't give us 0 because sine of 0 is sine of 0, of course, is 0 divided by 0. This is undefined, right? We can't necessarily say the exact value here. It's undefined. So it would be incorrect to simply state that f of 0 will be 0. So this statement is not correct. Just have to know that. And we're done for this question. Let's go to the next one. So now we are dealing with question 5, and question 5 says that if the derivative f prime of a function within the interval 0 and 1 in the set of real numbers at x0 exists, which of the following statement is true? The first statement says that f is continuous at x0. This statement is too ambiguous, and it takes a lot of assumptions, so it's not correct, because a function being differentiable, the derivative of a function does not guarantee that the original function is continuous. A function can be differentiable and not continuous, but a continuous function must be differentiable because it exists. So if you can prove that if a function is differentiable at a point, therefore it is continuous at that point. But if its function is continuous at a point, you can't prove that it is differentiable at that point. So that's the reasoning behind it. And option B again is too ambiguous because it is drawing a lot of assumptions that if the first derivative of the function within this interval exists, then the second derivative will exist at that point again. This is not true. It might be correct, but it's not always correct. So option C says that f is differentiable on 0 and 1, right? So in this case, we have been told that the first derivative of that function exists within that interval, right, of the first derivative. Now this gives us an idea about the differentiability, right? And the function is differentiable, therefore the original function is differentiable within the same interval. So I think this is also too ambiguous to be true. However, I'll go for the option that it is not correct, and if you think otherwise, you can share your thoughts in the comment section. So option D says that the first derivative of the function f naught is given as a limit as x tends to x naught of f of x minus f of x naught all over x minus x naught. So this is correct option. It's correct because this is a basic definition for the derivative of a function. Now option E says that f prime is continuous at this point. So yes, this is correct. Why? Because we know that this function is differentiable, and if a function is differentiable at a point, therefore it is also continuous at that point. So it is very correct for us to state that the function is continuous, because differentiability is a guarantee for a function to be continuous at that point. But a function being continuous is not a guarantee for it to be differentiable. So we have to take that into consideration. And the last option, f, is that f is a polynomial. This is not true. This is not true because if we consider a function, let's say y equals to e to the power x. This is an exponential function. This exponential function is continuous and is differentiable, but it's not a polynomial. So we can't draw a conclusion that this function is it's a polynomial function. So at least to the best of my knowledge. So I would say this option is not correct. That this is not it's not correct. So that's it for this question, and let's move on to the next one. Question 6 says that what is the derivative of the function f of x equal to the cos of the square root of e to the power x plus a divided by 2? What is the derivative of this function? Now with respect to x, where a belongs to the set of real number and it's a constant. Now to look for the derivative, this is a typical trigonometric function and there's a formula related. The derivative, let's assume that we have our function f of x to be the cos of g of x, another function. So to look for the derivative f prime of x, this will simply be g prime of x minus, right, because the derivative of cos is minus sine, the sine of g of x. So we are going to let our g of x in this case to be the square root of e to the power x plus a, which is a constant, divided by 2. So to look for the derivative of our function, we are simply going to have, this is a half, right? We have to keep that as a constant, and we look for the derivative of this function. This can be written as e to the power x plus a, all that raised to the power a half, all that divided by 2. So to do that, we are going to bring down the power a half. We differentiate the function in the square root sign. It will be e to the power x, because the derivative of exponential function e to the power x is e to the power x. Then we are going to copy the same function e to the power x plus a, and we reduce the power by 1. If we do that, if we take half minus 1, we are going to have negative a half. And remember that this 2 here is the same 2 here. So we can further simplify this as 1 on 4 e to the power x all over the square root of e to the power x plus a. Now that is our formula, our derivative of the function of our angle, because in this case that's our angle. Therefore, if we want to apply this formula, we are going to have our f inverse of x will simply be equal to negative, right? G inverse of x, this is our value 1 on 4, e to the power x all over the square root of e to the power x plus a, multiplied by the sine of g of x. G of x was the square root of e to the power x plus a divided by 2. So that's our derivative function, and we have to now compare this with the options given to us and then select the correct one. So first thing we need to check is the negative sign. Any function without a negative is already disqualified. So this without the negative is out, this without the negative is out. Secondly, we check for sign. Any function without the sign is already out. We see here there is tan, this is already out. We don't need to waste time verifying that. So we start looking for our 1 on 4. This one does not have 1 on 4, this is out. This one has 1 on 4, this one does not, is already out. This one no 1 on 4, this is also out. And we are left with option C, and option C says that f inverse of x is negative e to the power x sine of this, which is exactly the same thing we have, right? So this, remember that this is in the angle, yes, so this is like the entire angle, right? Yep, so this is like the entire angle, just to be sure. Now that's the correct option there, and that's it for the solution, and the C is our correct option. Now moving on to the next question we have. Now question 7 says that we need to build a box whose base length L is 3 times its base width W. The height is given by H. Different materials are used to build the top and the bottom. For the top it costs 10 euros per square meters, and for the side it costs 6 euros per square meters. The box should have a volume of 5 cubic meters. What is the value of the width of the base W that minimizes the cost to build the box? So this is more of theory and also application of derivative, and it's a very interesting question to look at. So let's collect the information given to us. We have been told that we need to build a box, right? Let's imagine this is our box, right? I'll just draw a simple box for us to visualize what we're dealing with. Good. So this is our box, and this is the height of our box. This is the height. This is the length of our box. This is our width. This is our width. Now the information given to us is that the length is 3 times the width. We know that the length is 3 times the width. We are going to call this equation 1, just to note. It's 3 times the width. It base 3 times its width. The height is given as h. We have represented that. They say different materials are used to build the top and the bottom. So the top is described by the length and the width, and the bottom, the side, is described by the height and the width, right? So different materials are used to build the top and the bottom. For the top, it costs 10 euros per square meter. So now let's collect the information. It says that for the top, right, is 10 euros per square meters, right? And what do we notice? That this square meters is the the formula for the unit for area, right? And we know that the area is usually length times width. Now since we are dealing with the top is described by the width and the length, right? So it since it's per square meters, 10 of these will be 10 length times the width. We have to take that into consideration. Now it says that per square meters, and for the sides it costs 6 euros per square meter. So for the side, what do we notice? The side is described by the width and the height, right? This is an example of a side, so 6 of them will simply be 6 euros. It says that 6 euros per square meters. Again, this is the unit for area, and in this case it will be 6. The height, the side is described by the height and the width, so it will be height times the width. Now what do we know? The question continues to say that the box should have a volume of, we know that the volume is given as length times the width times the height, and this volume is 50 meters cube, and this is the unit for volume. What is the value of the width of the base W that minimizes the cost to build the box? So that minimizes the cost, right? We're dealing with minimizing the cost, and if you can remember from the minimum and maximum value, to get a minimum value of a function, you look for the first derivative and you equate that to 0, basically the critical point. So that's the same application we have to use here. So in this case, what we have to do is we first of all need to represent all of our equations in terms of W. Why? Because we are looking for the width, and the options given to us here are all in terms of width. So in this case, from this we are just going to name this equation 2, name this equation 3, name this equation 4 for easy computation. So what do we know? We know that the top, right, the top is 10, the length is 3 width times the width, so this will be 30 the width squared. Now the side is given as 6 the height times the width. What do we know? We don't yet have an information of the height. How can we get the height? To get the height, we need to get that from the volume. The volume says that we have length, width, and the height to be 50. We also know that the length is 3 width, so this will be 3 width squared, right? If we substitute 3 width here, we're going to have this and the height here, so times the height will be 50. What do we notice? So the height will be 50 all over 3 width squared. We now know our height. We are going to name this equation 5. We know our height, we can substitute that in the side, so this will simply be, so we now know this, so this will simply be 6 into 50 all over 3 width squared multiplied by the width. We can further simplify this as this will go here 1, this will go here 2, so 100 width all over width squared, so this will be 100 all over width. Now to get a total cost will simply be the cost of the height, the cost of the top, and the cost of the side, right? So to do that, our total cost, the total cost CT, which is the total cost CT, this is not G, is CT, to be the top plus the side, all in terms of W. And how can we get that? The cost will simply be, for the top in terms of W will be 30 width squared, and the side in terms of W will be 100 all over W. Now to minimize the cost, the derivative, right, the derivative will be equal to 0, or the derivative with respect to W of CT will be equal to 0. So to do that, we are simply going to differentiate this function here, and to differentiate that, we are going to have 60W plus 100 into, this is like 1 on W, so to look for the derivative, this can be written as 100 to the negative 1, right? So we are going to bring the negative, we differentiate the function, we copy the function, and reduce the power by 1, and we have to equate this to 0. So we are going to have 60W minus 100 all over W squared. See, this will be 0. This implies that 60W is the same as 100 all over W squared. We can cross multiply, which means that 60W cubed should be 100. Now we just have to further simplify our result. To further simplify this, we have W cubed should be 100 all over 60. This is the same as 10 on 6. This is the same as 5 on 3. So W will simply be the cube root of 5 on 3. So W will be 5 on 3, all that raised to the 1/3. This is another way in which you can represent it. So that's our solution, and if we compare this with the options given to us, we can know the correct options to choose. So looking at the options given to us, this is not correct, this is not correct, so this is not correct, this is not correct, I think this is the correct option and this is not correct. So this is our correct option, and that is it for this video. Okay, so that is it for this video. Please do support my efforts by subscribing and liking the video. See you in the next one.